All right, good afternoon, everybody, and good afternoon or morning, everyone. Welcome, and thank you for taking the time to tune in to our event, Drones in K-12 Education. I do want to point out that I don't think we're going to have much discussion here in regards to that kindergarten, first, second, third grade. After having jumped in and naming this the Drones in K-12 Education, it was about a week or two into it that I realized, wow, I kind of just overbit here with the whole K-12. But the point that we want to make is we're speaking here about drones in the elementary school, middle school, and high school educational environment. So again, thank you for tuning in. We have some great professionals here with lots of expertise in regards to integrating drones into the classroom. So whether you're a teacher, a drone service provider, an individual that is looking to connect with your local schools and bring drones, you will find some insightful information here today. So without further ado, what I want to do is go ahead and I'm going to bring in our panelists one at a time so that they can do a brief introduction, who they are, the company that they're working with. And after that, we're just going to jump right into our three topics: engineering and build, coding, programming, and then mapping and modeling. So without further ado, I want to bring on Marisa Vickery with DroneBlocks to introduce herself. And awesome.
Hello.
So you can go ahead, Marisa, and just introduce yourself. Tell us a little about you and
Okay. Well, my name is Marisa Vickery, and I am one of the founders of DroneBlocks, along with Dennis Baldwin. And he found me kind of when I was teaching in a local school in Texas, and we kind of started creating this program. He had the idea, he's the technologist, and really the whole thing behind DroneBlocks was to add something exciting and new for kids in school. And so over the last 6 years, it's kind of evolved, and we've just offered a lot of new products and ways of learning, and I'm really excited to share and learn from you all today.
Excellent. Thank you very much, Marisa. And go ahead. We'll bring in Zoe now. Zoe Stumbough with, I hope I pronounced that right, I'm taking off hold, Zoe, with Outcast DroneWorks. So go ahead, Zoe, and just tell us about yourself and Outcast DroneWorks.
Hey, yeah, so my name is Zoe Stumbo, also known online as Zoe FPV. I'm the president of Outcast DroneWorks and head engineer at HES Systems for drone and UAV platforms. I have a background in drone racing. I was the first person to win an official FAA/AMA sanctioned drone race in the United States. From there, I kind of propelled myself into drone engineering as I was constantly looking for an edge on my hardware, and eventually helped develop out what's currently known as 3D flying for fixed pitch based drones. As you might be able to see in the video, I'm not sure how well the video is coming through, but essentially allows, this is my personal setup. I helped design the props, motor, ESC, flight controller, and this is my drone frame design. It allows for bidirectional thrust and allows you to have thrust in both directions, both positive and negative, so you can do crazy stunts you cannot do otherwise. From there, I went on to develop giant drone racing, aka X-Class racing, DR1's Pro Class racing, and multi-GP's Mega Class, all of which have used the hardware that I helped develop out for drone racing. So DRL has used my hardware, DR1's used my hardware. All of the drone racing leagues essentially have used hardware that I've helped develop and push giant drones. When I say giant drones, I mean like 1.5 meters in size, flying 140 miles an hour, big enough that if they hit you, something bad could happen. And then recently, over the last year or so, I started working at Outcast DroneWorks, a company I helped found here in San Diego, California, to develop out a maker kit. This is my latest drone. It's tiny, went in the opposite direction. Instead of big, I thought, how do you make drones reachable to the masses and not small? So this is the Microhawk maker kit. It has a Raspberry Pi Zero on top, which allows you to run pretty much anything that is Raspberry Pi compatible. using Python as a primary scripting language. And the Raspberry Pi is integrated into an open source flight controller using what's called iNav, which allows waypoint-based missions, full acro flying, like the video that I had up earlier. And yeah, it's very much a development platform for hardware and software. So you can modify it, it's easy to work with. And
yeah, and I don't want to cut you off, Zoe, but I think we'll jump more into a little bit details of engineering. I appreciate you jumping on and joining, and the information you're going to be able to provide.
Yeah, right on.
I'm going to go ahead now and bring in Jonathan McRae. Jonathan McRae is the CTE director with Scotland County Schools. So Jonathan, please go ahead now. I took you off hold. Here we go, and you're on mute. So if you just unmute yourself, and then please go ahead and give us an introduction.
Okay. All right. Thank you for having me today, Paul. I'm Jonathan McRae. I'm the Director of Career and Technical Education for Scotland County Schools in Laurinburg, North Carolina. And we are have completed 2 years of having a drone class in our Career and Technical Education program. And throughout these past 2 years, we've worked to prepare students to earn their Drone 107 pilot's license. We've had several students be successful with that. And now we've tried to expand the program even more as it's become popular. We've had, I think we had 4 sections in the class this year, but we also had some students who requested to start a business. So we have the Flying Scots Drone business, which is a couple of our students who were licensed, went out and got a contract to do the filming of a downtown festival around Christmas time. They're very successful with that and did all the photography and video and editing. And so we were proud of them. And then another group of students who'd been in a robotics program, which we were reorganizing, asked if they could build a drone. And we reached out to 9 to 10 drones and started our drone business, which and we were very excited about that. And unfortunately, when the pandemic started and school was canceled, we weren't quite complete, but we had about 24 students who were participating, and some students who had not been involved in drones before, nor with robotics. So it was an exciting opportunity for them. But we're looking forward to continue growing into next year and continue to expand our drone program in Scotland County Schools. Thank you for having me here today.
Yeah, excellent. Thank you, Jonathan. And yeah, that coronavirus definitely had a bit of an effect on us. So thank you. And we're going to come back. And now I'm going to introduce our last panelist, Jeff Epps. Jeff Epps with STEMERALD City. Taking you off hold, Jeff, so you can go ahead, please tell our audience a little about yourself and a little about STEMERALD City. Yeah, excellent. Thank you, Jonathan. And yeah, that coronavirus definitely had a bit of an effect on us.
Okay, Paul?
Yep.
All right, had some technical difficulties. I'm good to go. Hey, everybody, I'm Jeff Epps. I'm the CEO of STEMERALD City. We specialize in integrating STEM, science, technology, engineering, and mathematics into student core classes such as ELA, math, and science to raise their achievement in the classroom. We've been in business for about 3 years now, but we started back in 2009 working with students, and it's been a great ride ever since, and we're loving the ride to this point. So I'm looking forward to our discussion today.
Excellent. Thank you. Thank you very much, Jeff. And at this time, I'm going to bring on everybody and just admit all of us. And now just want to kind of jump into a discussion regarding the engineering and building side of UAS and the importance that has in education. Not just that we have drones that are getting built. We have pilotless air taxis, delivery drones. That is important. Not every student that is exposed, say, to drones is going to get a drone job down the road. But what is it that from engineering drone building, what are the skills that we're kind of introducing to students that they're going to be able to take and put into life going forward? So Zoe, if I could just kind of like start with you, and you can talk a little bit about that, and if you even kind of want to talk about the Micro Hawk and why, how is it that Outcast DroneWorks is helping integrate this?
Yeah. So I consider what's being taught in schools largely soft problems out of the hard problems. There's a lot of software development that goes on behind the scenes, kind of for drone development, how to interact with drones, but very little has really been done on the hard side of the hardware. And hardware really teaches you the physical limitations of the drone, how the motors work, how the electromagnetics in a motor work, the hard problem solving of how do you drive a motor and get it precisionally timed to actually create that RPM. The soldering, I mean, on a very basic level, kids these days, I hate using a term like that. Kids these days, they don't know how to use their hands, like shop classes have been kind of, gone with the wind, and, it's kind of hard to get curriculum based around, hardware. And, building drones, even if it's just a simple tiny whoop, I mean, really starts teaching you how these pieces are interconnected and go together on a more deep level. I mean, everything from your phone to your computer to your stove is largely built in the same way. It's an interconnected piece of technology, and every piece has its own individual component. And with building just a basic drone, you learn how those components integrate into a singular system at a fairly basic level. I mean, a drone is built up of motors, propellers, a drone airframe, a flight controller, and the electronic speed controllers that control the motors themselves. I mean, it's largely a 5-part system. So even though it seems, dramatically complex on the outside, you can really break it down into something that's, more, edible for the mind, something that you can actually understand the different concepts of and how they interplay with each other. And so that's one of the visions I've had recently, is like, how do we get more people into the hardware side and software side, and how do we integrate those two things? That's kind of where the Micro Hawk project came into existence. And for me personally, I mean, this is like a maker kit. You don't get this pre-assembled. It comes as individual components. It takes about an hour, maybe 2 hours, if you really don't know what you're doing, to assemble. And it teaches you, actually how to build a drone. And if you break it, how to fix it. And that's a big thing. We don't understand how hardware works anymore. If you break something with your phone, you just toss it.
Yes.
Although phones are a lot harder to work on, you can fix them.
So what you said is really great. You teach someone how to build it. And if you can build it, you can fix it. What I've seen in the beginning over 2.5 years ago, first starting out, a lot of folks are wanting to talk about repair. Oh, we got to teach folks how to repair drones. We got to teach folks. And it's like, teaching someone how to repair a DJI drone is nonsense, because there's no jobs in it, right? Their repair services is great. But teaching someone how to build a drone, put those arms together, tie the motors, if something were to happen, they could pick up a drone, look at it, and diagnose it based on the fact that they've built an entire one themselves. And I just want to bring up real quick a screen share of a schematic, because you talked about the components, which most folks, they look at a drone and they can do such fantastic, crazy things that you'd think they're complex, but you just have 4 motors, some ESCs, a flight controller, a gyro, and a receiver with a battery. This looks like crazy foreign language. But like you said, within 1 hour, you can walk a student through this and it can start to make sense. But if you don't show a student how to actually plug and put these together, they will never understand and comprehend this. Because I can tell you from going through a U.S. Army aviation electronics course, when I started that class, I was scared of those schematics. And that's why now I love sitting with students and taking something like, whether it's this F450 with an Arduino, it's complex. But once they get done looking at that, they're like, wow, that's easy. And it doesn't matter if it's a pilotless air taxi, right? It doesn't matter if it's a delivery drone, big or small, they're all utilizing the same components and the same operational standpoint, if if that makes sense.
Mhm.
I would say with like maybe Jonathan here from that CTE career and technical education standpoint, when you're building and engineering a drone, you're looking at these schematics, you're learning about motors like Zoe said. How does this relate to other industries? Is this a skill that is going to help folks, not just in, like I said, in drones?
Definitely. And we don't, it's the drone's the hook in a lot of times in the case to get the students excited about it, but more it's about teaching the teamwork, the critical thinking, how to problem solve, how to use the documentation that you have, like the schematic that you showed, to then read and learn how to fix it, or what did you do wrong and problem shoot it. So we've done robotics for a long time, and then our robotics students asked to build a drone this year. So that's what we did, and it's just a new level of excitement again. But it was that teamwork, and I think putting them in the teams to work together, and we had a kind of a mentor from each of our different disciplines. We had our plumbing teacher, our electrical teacher, our drafting teacher, and our coding teacher serving as coaches. So you kind of had different disciplines even working with that. And I think the teachers are having just as much fun as the kids and then learning a good bit of it. So we're trying to let students see that it's not just about building the drone, that it's an awesome output at the end that you can go and fly something that you built, but it's that accomplishment of finishing something as a group, as a team, and trying something different, because none of the students in the room had ever done that before. Even though they built a robot, there's a lot of different kind of variables here, and they had to go in this other direction. But again, we had Paul, you remember there was one new team showed up like maybe the second or third day of the build, and they just jumped right in and caught up very quickly because that's what they were excited about doing. And again, we didn't mention this was all after school for about 2 hours each time they came after school, and they were excited to be there.
Yeah, it's phenomenal. And like Zoe, I mean, even like Zoe said, like the programming, it's your microwave, it's your oven, it's your washing machine, and it's just electrical components. So now you can take this knowledge and learning and you can go apply this to a vehicle or anything else. So to kind of help make the transition here, Zoe, with you mentioned it, it's motors, it's ESCs. So we're building this drone, and give us a brief understanding maybe of how the receiver might pick up a signal and it just goes from that ESC to the motor, and just so that we can set up the coding and programming aspect, like we put what together.
Okay.
And
okay, so let me break it down as simply as I can without going into too much detail. So you have your controller. From there, you have an input signal of what you're doing. That input signal is raw, so it's a value of like 1,000 to 2,000 in a lot of protocols. That's sent wirelessly in a protocol to the receiver. And the receiver gets the raw signal that's sent from the transmitter. That's sent to the flight controller. The flight controller then interprets that signal, integrates the data with the gyro and accelerometer often cases. And then from there, it's using, basically it's trying to figure out what to tell the motors what to do. And the motors are controlled by the electronic speed controller. So that basically just a regular PPM signal sent down to the ESC. The ESC gets it. But now the ESC has to convert that signal and what the flight controller wants it to do into electromagnetic fields that actually control the motor. So each motor has 3 wires. So ESC is firing off signals for each wire, which creates induction on the bell housing of the motor to actually spin the prop. And that process is kind of magical because magnets, how do they work? I mean, one of those things that's still kind of a mystery to a lot of people. But it's really cool because it teaches you that, if you integrate all these different sensors and what you want to do with a little bit of programming, I mean, PID loops are fairly simple. The flight controller is using a PID loop. It's taking the data from the sensors, and essentially it's trying to correct the error of what's happening with the motors to create stable flight. And a PID loop is used in everything from traditional robotics down to even your microwave, trying to keep the right temperature as things change. and some, I wouldn't say your fridge is just, you know, simply just getting temperature and trying to turn on and off again. But there's a lot of things that are using PID loops, and it's a very simple code base. So within that, oh, sorry, go ahead.
So I was going to say, so we put these together, and what it is manually we can control it by using a remote to adjust these different numbers, leveling the drone, flipping the drone. What we also now have is, once we put it together, is we can access this with a code, or if we write a program, we can just automatically send these numbers to the drone. And if anything happens where it goes left or it moves right, this drone's going to auto correct itself, based on the connections that we've made and the setup that we've designed.
And that's kind of the brilliant part. I mean, so you're basically, I see it as, you know, the motors are the hands, the arms are the ESCs, you've got the flight controller, which is like your nervous system, and the ears are the receiver. And when you create that brain, that piece of code that helps run all of that and kind of interfaces with it, it kind of allows you to do a lot of brilliant things. I mean, anywhere from drone swarming, where you coordinate multiple drones to fly together, object recognition / environment mapping to have the drone fly itself, to even, you know, RF detection, where the drone's flying around detecting RF and actually building a map of the RF environment, you know, the signals going through there, your Wi-Fi router, your phones, the Bluetooth. And that's the brilliant part, is like, once you have that nervous system, the body built, it's really, you know, sky is the limit. Oh God,
yeah,
that sky is the limit of what you can really do with a drone.
Yeah, so what I would say from the build and engineering standpoint is there are options out there. There are kits out there. There are some super easy kits that kind of take away from the wiring, the electrical diagram. Not to take away from those, but from an educator, a teacher with less experience, that is a viable option. There's also kits out there that are a little bit more required. They require that soldering. They require an understanding of wiring schematics. So those options are also available. So to any educators, teachers, instructors out there, from an engineering design build, there's options available. Outcast, DroneWorks, like we said with the Microhawk, you can check out their site and how they're trying to make it not just to one group, but let's make drone build and engineering accessible to the super hobbyist folks that have never done it before, but also folks that want to do a little bit more advanced. Then locally, I would say to folks, connect with folks locally, because 910 Drones with STEMERALD City, we've connected with Scotland County here in North Carolina. We've connected with the Need Academy to help them integrate these drone builds, especially to do it from that more technical experience field. There are folks out there that will help you with these things. So Google search local drone companies, drone businesses, and talk with those folks to see what options might be out there. But now what I want to do is move into this coding and programming, which is, it's just as amazing, because it's like you built this machine and now there's so much we can do with it. I compare it to like a computer. Folks get their computer and then what do? They turn it on and they browse the web. They go on Facebook. But how many folks are like bringing on programs that might be able to help them do this? And I'm not a computer guy, so I'm just going down some awful rabbit hole. I'm the guy that just surfs the web, even though the computer might be able to do a bit more things. So I think drones are the same, where people get it, pull it out the box, they just fly around and take pictures, never realizing like it has all these advanced features and ways that you can tie more into it. So DroneBlocks, huge folks on here. If you're a teacher, instructor, if you haven't heard of DroneBlocks, you need to YouTube DroneBlocks, get on social media, find out about drones. But I'm going to stop talking. I'm going to let Marisa here, who has lots of experience within education and working with students and doing that with DroneBlocks. So Marisa, I guess we have a drone now, we want to program and we want to code, and why is this important? What is this doing for our students integrating this type of lesson skill to what we're doing?
Kind of in a big answer, I think, is giving every kiddo we can the opportunity to do partly what we need them to do in the future, but what they're good at. We kind of started DroneBlocks. As I said, I was a teacher at elementary school, and you had mentioned reaching out to people in the community, and Dennis Baldwin was a parent and came to me, and the first thing we did is kind of like, you know, where Zoe comes from, is we 3D printed bodies, and we wired and soldered. We had dads come in and help us, and we did in teams, created these really phenomenal drones, and it was the most incredible project I've ever done teaching. But on one hand, we quickly realized that we were spending so much money on the parts and so much time that I wanted teachers and students who didn't have either the skills or the money to build these things to still be able to learn to code. And I say this coming from very much an English ELA background, music and art and dance. So everything I've done with DroneBlocks has been completely out of my expertise. And I really wanted students and teachers who don't have that background to be able to teach it and bring it into their classrooms, either for free or, you know, in an affordable way. So we started with the drag and drop programming with DroneBlocks, and Dennis Baldwin made the app free. And this all started about 5 or 6 years ago. And now we've kind of grown into a second app, which is called DroneBlocks Script, which is like programming through JavaScript. We've also incorporated workarounds with Python and Node-RED, and everything is based on what Dennis uses with the SDK. It's all open source. So you have somebody, you know, a teacher like me that doesn't have that computer science or engineering or technology background that can still bring something like DroneBlocks into the classroom with even a, you know, $95 Tello drone, and bring these opportunities to these students that are waiting for something like that. And then, you know, 20 years of teaching, and don't hit me for this, but school's boring when we are stuck having to teach all the standards, and there's so many restrictions, and the best teachers, they're able to reach all their students, but it's difficult. And so when you bring something like a drone in, connect it to an app that it does something, and you can give students a challenge, whether it has to do with the arts or has to do with actual coding or search and rescue challenges or math. If you can reach a student that way, it's worth its weight in gold. So that's kind of how we started, and that was really my motivation of doing something so completely out of my background and expertise, is just to provide this opportunity. You know, we keep going back to what Zoe said about everything's programmed, from our hairdryer to the microwave, and we need students to go into this type of job expertise. And I'm a huge fan of trades as well. I just love that Jonathan mentioned that they have a plumbing teacher. That's incredible. And I love that students have the opportunity to see how all these things work, and hopefully latch on the one thing that really sparks their interest and will help them be successful.
Yeah, that is excellent. And I think I was just listening to you and lost track of what I was going to say. It was, with the DroneBlocks, I think it's similar. What are you laughing at, Jeff? I forgot. I'm being honest. I'm just going to make stuff up. I love you, Jeff. Did it again. The DroneBlocks. Oh, with the computer, right? So DroneBlocks is this free app that you can get, and the fact that it's free, I think that might make some folks think that it might not have as much value, because if you just jump into DroneBlocks and you only use it for like takeoff, land, fly forward, it can become boring. And if you're not creating lessons around it, right, you've got to have a challenge. Jeff says it all the time. If it was, I'm going to butcher it, but if it was easy, Jeff, what is it?
It was easy, everybody'd be doing it.
Yeah, right. Well, he tells the kids that all the time, and they hate hearing it. But it makes sense. And if things are easy, the students stop doing it. The easy stuff, they stop doing. So with DroneBlocks, and I think what we've seen more recently, and you can talk to it more, but then also I want to hear Jeff talk a little bit about the Remote Pilot 101, which is utilizing drone blocks. And it is creating a lesson, creating a quiz, you know, making it so that there is a challenge, not just giving open drone blocks and say, hey, program this drone. It's like you mentioned, search and rescue. It's saying, hey, this is the mission. We have to get from here to here, and this is why, and this is what's in the way. So I think that's awesome with what DroneBlocks has done, and more recently with the DroneBlocks membership and the lessons that are available.
Yeah, we really try to make it so everybody can have access. We do still offer, you know, the apps are free. We offer some free curriculum to get you started. And then we've tried to recently give options for a membership or purchasing the lessons, just to kind of accommodate every school situation or every need. So we hope that you're able to utilize that. And we're just really excited that so many of you have heard of it and are using it.
Yeah, and I think the community too, because if you get into the community, talk with more folks and say, hey, what have you done? What challenge did you create? What, you know, what is working with your students? What's helping you? Because Jeff, I need Jeff to jump in here in regards to like the lesson, the lesson plans, and being able to, what we're doing, what Jeff has done a great job building out, is mapping the environment on a PDF. So now students, come on, Jeff, you can talk about this.
Well, yeah, thanks, Paul. And Marisa, I have to tell you that, I mean, DroneBlocks is just incredible. And you know, I praise you and Dennis. And I do want to hit on one thing real quick. As with an English background, your background is storytelling. And that's what made you so great for this project, because essentially with DroneBlocks, you're essentially telling a story to a robot, and it's carrying out that story. Okay, so kudos to you on that. You know, I want to touch real quick on engineering. I think sometimes in education, we all get confused with engineering, because when we think of engineering, we think of an engineer. Well, an engineer is a career. Engineering is a process. Okay, it is a process for solving problems. And when you can implement the engineering process, okay, into core subjects such as ELA, science, and math, you're essentially teaching students to create solutions, and that's what engineers do. Now, with regard to science, you know, the science in STEM is geared toward the scientific method. You know, as I've talked with employers, that's all they talk about. We need employees that know how to solve problems using the scientific method. Well, what is that? You change something, observe the results. Change something, observe the results. And that's exactly what you do with DroneBlocks. So it's an amazing product. You know, when we started the remote pilot program, it was born out of COVID-19. I was working with the Northeast Academy up in Elizabeth City, and with my advice, they went out and they bought 16 telos, okay, and they bought batteries and all of this stuff, and then we all got quarantined. So then the STEM director called me and said, "Well, Jeff, what are we going to do with these 16 drones?" Good question. So I then reached out to Paul and I said, "Well, Paul, what if we were able to have students connect to a machine here at STEMERALD City and then actually pilot the drone using DroneBlocks?" And so we came over to STEMERALD City and we tried it out with multiple cameras, and the students loved it and the teachers loved it. But the real great thing about it was we were able to introduce the scientific method and engineering into a high school classroom. Paul, do I have permission to share? Can you give me that?
Yes.
Is that a fee or something? I know how you are. Is that a fee, or you're going to just like give it to me for free? You're not going to show out in front of company?
I don't know why. You're funny. I don't know why I can't. Goodness.
Got it?
No, what do you want to share? What is it you're trying to share, like the video or something?
Yeah, no, I want to share a screen on my computer. I just wanted to show them with what one of the lessons looks like let's see, and it says I'm still disabled. Okay, well, never mind, Paul.
Yeah.
Here's what we'll do. So what we did was we basically took a story, right? And we said, and I'm going to read it out to you exactly what it says. It says, this was a sample mission of what we did. It says, the drone must take off from waypoint 1, fly forward about 48 inches to waypoint 4, turn and fly back in the opposite direction about 48 inches and land. Okay. Now,
Can you share now, Jeff?
I can share.
Look at that. I figured it out.
Thank you. Thank you, Paul.
Diagnosing.
All right. So this is what one of the sample missions looks like. We wrote it out in plain English. Okay. And then what we did was we challenged the students to use the coding interface in DroneBlocks to carry out this story, to tell the robot this story and have it fly it. Now, we also gave them diagrams. So what we put students in teams, just like Jonathan said, you put students in teams because it forces them to work together. And so we had a mission mapper who actually had to map the mission, and we used Google Slides. We had a coder who actually had to write the code. And then we had a visual observer who had to oversee everything, okay? And all three had to communicate with each other to make this work. And it's worked out really well to the point that we're now looking at more complicated situations and scenarios for the students at the NEAT Academy. We then transitioned students over to your DroneBlocks code application, Marissa, where they actually now had to write the code. There was no more block-based coding. They actually had to write it. Now, I say all that to say that this caters to two different learning styles, okay? It caters to students who are spatial thinkers, but it also caters to students who are what we call computational thinkers, students that really thrive on things like coding. So this was a great little tool for us to use during the pandemic, and it worked out for us because we were struggling to figure out what to do with these 16 drones. So now we're moving on into swarming. So next week, I'll be doing a session with students using the telos, and they'll be actually coding the telos to swarm. So they're really excited about that. And last but not least, you know, Paul and I, we have these discussions all the time about students and, you know, getting students involved in the process of building drones. Well, Paul sourced out the parts for a kit. We built a kit. And I think it's the end of this month, last 2 days of this month, we'll be up at the NEAT Academy. And we will be actually, the students will build the drone the first day. So they'll learn about ESCs, they'll learn about motors, they'll learn about the Arduino and the code behind the Arduino. And then the day 2, they'll actually get flight training. So they will fly the drone that they built. So there's a lot that can be done with drones in the classroom. And there's a lot with math and science. But I will say this, and then I'm going to close out my portion. It boils down to professional development for teachers, okay? So if I have any educators that are listening, okay, it begins and ends with you. And I could say that, you know, learning to program a drone and integrate it into the math classroom, the ELA classroom, or the science classroom, it is not a difficult task, but it does require professional development. And I visit schools all the time, and I see boxes and boxes and boxes of parrot drones and tele drones sitting in closets, brand new, untouched by human hands. So if there are any educators out there, now's the time to go in that closet, pull these things out, create some kits that can be delivered to your students at home and really energize remote learning. Thank you.
And what I would say with this, the whole mapping and modeling, or the coding aspect, and what we've done is showing students how to write that code to program the drone just to do a lawnmower pattern. Like just having the students understand that a drone goes up, down, turns around, comes back, by saying, hey, we want you to create a map of this area. They're understanding what the drone is doing when it's in flight. When
Hey, Paul, I don't mean to interrupt you. Can you stop my share?
Yeah.
Somehow it's not stopping. I can't see the controls to stop it. There we go. Thank you.
So what we're doing is, where I was at was, with in regards to the whole drone industry, it's introducing students to the coding and programming, because that's where the industry is heading. That's where jobs maybe are going. It's not just piloting, it's all this software that's being developed, whether it's SkyBrowse, and I'm just going to go on the mapping stuff, Measure, Pix4D, Drone Deploy. These are all software, and I'm going to do a screen share real quick here just to explain to some folks. This is right here is a drone deploy. So we're creating a map and model. So when we want to change the area that we're mapping, we're dragging it out. And based on this area, the size, the drone or the software automatically adjusts. I can get that. Of course not. I'll just do this one. So it's automatically adjusting this pattern and moving all this, and that's all code. That's a code that's going into this drone in order to give it commands and tell it what to do. And having students understand that, so that it's not just, hey, take this drone and go out and map, press 3 buttons. This is how easy it is. It's having students that understand, well, what if when I hit the button, the drone isn't doing what it's supposed to do? Why is it not doing that? How can I improvise? How can I adapt? How can I troubleshoot this issue? You know, there's all these different little tiny things, PID loops. I'm going to sound stupid here, but you know, all those methods of communication, there's ways to somehow they get hung up or stuck up, blah, 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 just like my word. So if we can help educate students on not just and this is the type of person I am from the military, flying, it's not just why do it, but, or not just do it, but how, or why are we doing this? And that's what's phenomenal about the coding aspect, is that we're getting students to understand there's more to the drone industry than just the actual hand skills. There's all this coding and programming, and mapping and modeling is like, I think one of those first ones where we've seen the coding and programming it. But when we start to look at utility inspections, we're going to put a drone up that has specific sensors, and that drone is going to be able to stay right in line with the power lines, not because it's mapped that way, but because it's recognizing the actual power lines. And when it gets to a pole, it will recognize that pole because it's part of its code, it's part of its program, and it will take 1, 2, 3, or 4 pictures maybe. And that's the future of the industry. And that's why the coding programming side is what I think so important. And as was noted, is this isn't necessarily new stuff, coding, programming, PID loops, things like that. It's just that now that we're flying and we have these cool pictures, it's all getting so much more attention. So again, it's that hook. It's the way to bring students in, because they might take this knowledge and now go work for an autonomous vehicle, because these vehicles that are driving up and down the roads, they're utilizing the same sensors, the same software, the same principles in order to be able to go out into an environment and kind of drive itself.
Paul, you kind of touched on it too, is not just mapping, but there's so many industries. And basically, we're providing the practice and the soft skills, like you all kind of touched on problem solving, persevering, and being stubborn, really, and to keep trying and figure out the solution, whether you use drones or programming in agriculture, ranching, safety, security, search and rescue, shipping. There's so many applications, and everything you said is right on, in that we just want to give these kids opportunities to practice and to learn those skills. And I think it's brilliant. What all of you are doing is just so cool.
Hey, Paul, real quick.
Yes.
I want to switch my video over to a couple little toys I have here. And I also have my partner in crime on here, Dr. Cynthia Reeves. She's one of the attendees. She's the Associate Dean of Grants and Special Projects at Richmond Community College. And you know, anytime I'm up to no good with STEM and robotics, she's usually not too far from my side. One of the things we're doing this summer, and we're talking about how do you integrate or introduce students to robotics without overwhelming them? Well, we're working on a variety of projects here. This one here is a robot that we've put together. And you know, it's a robot that students build, and then they use a microbit to code it. Okay, this microbit, this processor is $16.50. Okay, that's not expensive at all. It comes with a temperature sensor. It has an accelerometer. It has a compass. It has Bluetooth capability, and it's this type of technology that makes it easy to get our students' hands dirty with robotics and technology. So I think Marisa was talking about, you know, studying, using robotics to investigate the environment. Well, we've created a workshop, a summer camp called Get Outside for a Bit. Get it? A bit, microbit, get outside for a bit. Okay, but this workshop, or this particular STEM camp, is about students getting introduced to robotics and using the microbit to sense air temperature, barometric pressure, the temperature in the room. We even have a soil temperature sensor that they learn to wire, right? They got to wire it, and then they have to code it and go outside and stick this in the ground and take the soil temperature every morning, and they get to remote sense their environment. Remote sensing, that's another component to drones and UAVs, being able to do that. So
yeah.
Imagine students being able to first design a temperature sensor, and then taking that temperature sensor and mounting it to a drone that they built, sending that drone up into the air, gathering that data, and then using that data to solve a problem. That's what brings all of this together.
And to bring that together, drones are a delivery system, and what we're seeing in hazmat, I had a great conversation with a woman named Denise yesterday with Squishy Robotics. They've got a payload that the drone drops this sensor. So for hazmat situations, you're dropping a 4-gas sensor so the drone can continue to do its job. And Jeff, you and I had a conversation a little over a year ago about coming up with that drone that carries a ground drone and drops it somewhere and lets that ground drone go off. And this is the same thing that Denise mentioned that they're working on. And like I told you, this is Mars stuff. This is lunar, this is space stuff. Launching an aircraft to somewhere else to drop a ground rover. And then that ground rover goes out and collects data. I mean, that's NASA stuff, but think of large construction sites where we're gonna have a ground rover. A drone might pick it up on command, bring it to a different spot, and that drone's gonna go out and do some sort of data collection. But yeah, that's all great stuff. And what I want to do here to bring it in and make sure that we hit the 3 topics that we had discussed is we covered the building a bit, we covered the coding and how to start somewhat implementing that, and this idea of mapping and modeling, because we can now code and program and tell a drone what to do. So whether it's like we saw with the drone deploy screen, where you can take pictures, or if it's this new photo video grammetry we see with Skybrowse, where you have a software, you click a button, the drone automatically does a circle around the location, filming it 2 videos. And then it takes that video and it turns that video into a 3D model. And it does it in not hours or days. It flies the site in 3 minutes, and then it creates the model in 20 minutes. So if your class is an hour long, 90 minutes long, you can take your students out to the football field. You can set up some cones. You can set up some type of objectively gradable assignments. And then you can fly that with the students, walk back in and have it all processed within the same class. And then you can hand the students like 10 questions and say, what is the length from here to here? What is the area of this end zone? What's the area of our end zone on the football field? And it's not that that question really matters unless maybe you got the groundskeeper guys like, hey, we need to get some fertilizer for the football field. What's our square feet? You know, that might not be the case, but what you're doing is you're having students collect data. They're flying a location like a mission, and then you're saying, hey, take this map and pull data from it. We need you to extract this data. So we have them, they're just learning software. They're getting in, they're seeing if you click this, it does this. If you click this, it does that. I think it's like what Marisa said, it's putting out folks that have some experience. So I want to do a quick screen share, and maybe Jonathan, if you could touch on from like, again, that CTE level, why would skills like this help someone going forward in the drone industry, but then also just in general? I'm going to show this map right here. So if you guys can see this. And Jonathan, are you there?
I'm here. Yeah. And I think what we're finding is that, you know, we first started doing the drones, it was all about the 107, and we're starting to see that it's a tool. And it's simply a tool within many industries that can be utilized. And mapping is one part of it. I got the chance to be on a mission with you once when you were mapping a farmer's field and saw the agricultural applications to it. And we stressed over and over again when we were talking about it, that unless it has a positive return for that employment or for that business owner, then those applications will fade away until it gets to be a positive return for them. And I think our students are starting to see that, because essentially with drones and putting them in these situations where they're having to be problem solvers, we're preparing them for jobs that we don't even know will exist. Those jobs that haven't even been invented yet. And if you think about 10 years ago, someone was going to tell you they wanted to grow up and be a professional drone pilot, I don't think, you would have kind of said, oh, well, maybe that's the dream that you'd have one day. The price point was so much more expensive. But now it seems like everybody, can go out and get their 107 and become a pilot. But then it's the application. What's the niche you're going to put it into? And we're seeing that the mapping application is a big part of that. And we'll be offering that as part of our curriculum next year. So we're actually getting our drone instructor trained to be able to do the mapping piece, so we can add that to our curriculum, because we think that's the direction that if students want to go into that we want to make sure that we can prepare them for it. But the more skills that they can add to their collective drone knowledge, the more employable that they will be. And again, as somebody said earlier in the presentation, they may not be going into a drone industry, so to speak, but they may be going into a construction job and have this drone skill, and it puts them ahead of the line of people applying for that job, because the employer wants to have somebody with those skills. So we're trying to tell our students, when they apply for jobs, are the first ones getting called back to come in for interviews, and then they can impress them with the skills that they have. So, again, like I said, I don't always know what jobs they'll be doing in 10 years, or even 20 years from now. But we want to make sure that they're prepared with those base skills so they can apply the knowledge they have to almost any situation. And we're excited about being able to offer mapping in our drone Part 2 class, which will be offered next year for the first time in North Carolina. So we're excited about that.
Yeah, and that is absolutely great news, because like you said, it's a tool. Public safety, fire, police, emergency manners, all using drone mapping, construction, virtual design construction, building information modeling, using drone mapping and modeling, agriculture for crop scouting, using drone mapping and modeling, surveyors that are doing elevation and boundary, maybe not boundary, but the elevation and different type of reports for the progress of big sites. They're doing mapping and modeling.
Paul, one of the things we're looking at is, you know, if you said in all those industries, we don't want just our drone teacher to be the one with the license. We want our public safety teachers to get their license, and we'll have a drone for them to use in their class. We talked a long time about with construction, being able to do inspections within buildings, roofing and things like that. Our agriculture department.
Thermal inspections.
Sure, exactly. So if we could get every one of our teachers a drone license, then we, you know, each teacher that's able to get and earn their drone license will get a drone for their classroom for them to use within the lessons that they'll have. So want to see it more as a tool and not just that one specific niche that, because we've had kids that gone out and made a business on taking photography and doing videos, but we know there's a bigger world out there than just that, and want to make sure they're prepared for all those things.
And I do want to make that point, because entrepreneurship is that get your 107 and you can, but we're not saying get your CDL. We're not having all these students get like a CDL and say, hey, you could be a truck driver. Well, why? Is it because truck driving is not as cool? It's like drones are the hot thing, and it's that leg up. That 107 is that leg up, but it's the hey, get your 107, you can run your own business. Well, we're gonna give you a class in entrepreneurship too, because that business, you know, own and operating your own business can be a difficult task. But I do think that is definitely something. The 107 is a great. When I was growing up, I used to hear, especially in the military, right? Having been in the military, everybody's graded on these scales. Your PT score, your such and such classes. I can't think of the classes, but like everything's on a scale. So when it comes to who gets promoted, it's like, well, whose PT score is better? If they're the same, then they say, well, whose is better? So if you look at the commercial environment, they're going to say, well, you both want to be project managers. You're both applying to be a project manager with Clancy and Thay's Construction. Well, you both have an engineering degree. You both have a PM certification. You both have a PM certification. Oh, you have a Part 107 certification. Oh, but you don't. Oh, well, we're starting to integrate drones, and you'd be able to give us monthly updates, and we don't have to give you training. So it's like, hey, that's the leg up.
Hey, Paul, before we break, I think you probably want to mention the Part 107 offering for high school students.
So you can refresh me. Is this similar like with the NEAT Academy?
Yep, same thing.
Okay, definitely we'll do that. And then, so I think with this idea, like we said, we can start having students dive into this engineering building. What is an ESC? How does this communicate? Because this same protocols that drones are utilizing are being utilized by, hey, autonomous trains, right? If trains become autonomous, they'll follow the same thing. Pilotless air taxis, autonomous buses. Integrating this into the classroom is going to help folks not just from drones, but it's skills that can cross into different regions. Whether, and I love that Zoe, I think Zoe said it, or maybe it was Jeff Jeff. Engineering isn't just like the building part, right? We have software engineers. They build software, code, they're engineering virtual environments. So we've got to pull our mindset away from, hey, engineers, drones, hardware, cameras, payloads, to, hey, engineers, software, coding, programming. The coding, the ability to get kids to see that, hey, with the Zumba vacuum, why does it work when we're not home? Oh, because someone's always telling it what to do or what not to do, just like the pool vacuum. So figure out how can we integrate this, not just from a drone standpoint, but from English, that literature side, the math, and other aspects of education. And then the mapping side, we did this quick, showed you a brief look at a map, but from a classroom environment, a geography class, we can actually go out and map our local geography and then do some sort of questions and assignments on that. Or we can take it to a math class and we can ask students to say, hey, draw and identify as many right angles in this model that you can find. Or find the surface area of this specific area. Or connect like you put blue cones out, connect the three blue cones. What type of triangle is that? Is that an obtuse triangle? Did those three cones create an acute triangle? So it's so great how drones are, again, they're a tool. And I want to stop talking. I want to give each of our panelists the opportunity to, just kind of wrap things up, tell our viewers, what it is from their perspective, and just share any bit of information. Please go ahead. I'm going to ask you, Jonathan, if you just want to kind of start us out.
Okay. Well,
put you on the spot.
Yeah, no problem. Appreciate you having me today. As we're going into this next school year, a bit uncertain of how that's going to operate. One of the things that we are looking forward to doing is continuing to add drones to our curriculum and get more teachers certified. We're working with our staff right now and giving them some prep sessions, because we just understand that the more teachers that have that knowledge and have that skill set and have that comfort, feel comfortable with the drone, then the more likely their students will benefit from that also. So we really want to make sure that our students have that access, that it's not just a small group of students who can stay after school, every Tuesday and Thursday, but that it's all students that want that opportunity, can take it in a class at the high school. We'll see it as a part of they didn't take the specific drone class, and they might see it as part of a public safety class or a construction class. Or if they're in middle school, they might choose as an elective to take one of our STEM classes or one of our coding classes and then see drones incorporated in that. So we'd like to see that as being a part, and again, it's the hook. We know that it's a tool and to get a step ahead, but we really want it to be able to be the vehicle in which we teach them those critical thinking skills, how to work as a team, and how to solve problems that we don't even know exist yet, and be prepared for that future, be that future ready student.
Excellent. Thank you.
Yeah, thanks for having me today. I appreciate it.
Yeah, thank you, Jonathan. And then Jeff, I'll go to you. Jeff's not paying attention.
I'm paying attention.
Slow on the draw, Jeff. Slow on the draw of the mute button.
All right. So thank you for having me today. With STEMERALD City, our primary focus is integrating science, technology, engineering, and mathematics into core subjects. And that has to happen with PD for teachers. We're getting creative on our side because, as Jonathan said, we really don't know what the school's year is going to look like. We have some idea. So we're preparing for remote learning and delivering sustained professional development for school districts, teachers, and educational organizations that can deliver full remote learning activities. And drones, that's a major part of that. So that's what we're focusing on. But the main thing I would like for all of the attendees to take away today is, with drones or robots, as I refer to them, they're nothing more than robots that fly and take pictures. There are three core components to robots: coding, 3D modeling, and electronics. Okay, all three of these disciplines can be integrated into student learning to make learning more tangible for them. And in parting, I want to say that Paul and I, we are so committed to putting certified drone pilots on the campuses of high schools that we have released a Part 107 certification portal on STEMERALD City's website that's free for any high school student. And we are requiring, only thing we're requiring is the online class is available to them at no cost. And we're requiring them to be finished with the coursework by the first week of August, okay? Because I'll get an email when they finish. And those students who are finished, Paul is going to donate his time to test prep, prepping them for the Part 107 test. So all the students have to do now is pay for their test, But the great thing is then hopefully every high school would have a Part 107 certified pilot on campus. So if a teacher, Jonathan, if one of your teachers at a middle school says, I would sure love to have some photos of this area of Scotland County, there is a certified pilot right there in your high school that can go over there, grab that information, pull it down, and get that information to the teacher. So that's our commitment to education, and we're excited about it. And once again, it's a pleasure to meet you, Zoe and Marisa. I think you're some cool cats. That's all I can tell you. You guys are cool. And Jonathan, you know, you've always been cool to me. And Paul, you're working on it. Keep working.
Yeah. Hey,
thanks, everybody.
hey, all you cool cats and kittens. Anywho, so thank you, Jeff.
Did I hit him so hard he froze?
I know, you froze him.
I froze him. Let me see if I can unfreeze him. Let's see. Pow. Pow. It's that STEM magic, you know.
You made him speechless.
If it's gonna fail, at least it failed at the very end. Oh, it's too bad.
Well, Zoe, just take it over.
Yeah,
you're now Paul. You are now Paul. You are now Paul.
I mean, it's because we're live on Facebook, so I guess I'll have my closing statement. I wish I had a program like Marisa's DroneBlocks when I was in elementary and middle school. I mean, that would have introduced me into a whole new world of coding that would have been innovative and fun for me to actually get my hands on. And I also wish I had the hardware experience. I mean, I didn't know anything about hardware until I was on my own wanting to get into drones. And I learned how to solder for the first time on the flight controller I bought in Japan from a very nascent maker of flight controllers. And that set me on a deep dive into engineering. And this is one of the biggest things that's really close to my heart, is that we have to get kids meeting that engineering aspect to that code aspect. And, you know, it's like the left and right brain thing. And once we combine those two things, it really opens up the world of possibilities. And I'm really hoping that schools will start focusing more on engineering and adding to that code, because there's a lot of courses for coding, not so much for engineering. It's like, for example, the Microhawk project that I've been working on. I think I haven't been, the only reason it exists is because I have not found any other robotics kits that you can build out that fly and then allow you to program that from there. And that was kind of what spurred that on, is like, I'm hoping there's going to be more of those going forward in the future, because those are the kind of things I think are going to really take that, you know, intro level to another, you know, advanced level, and allow people to develop out the skills to create the next best thing that, you know, comes after it. And it's really exciting to see. I mean, I'm also a bit of I have a pride in my country, and I want to see America get back on top when it comes to STEM and engineering. There's a lot of other countries that have really kind of hit it out of the park with their STEM programs. I feel like we've kind of been left behind a little bit. And the work that everyone in this room has been doing is really pushing that forward, and that has me excited about the future, the possibilities that have been created. So I just want to say thank you all for having me. Marisa, you're awesome. I love your project. Like, I almost want to say, hey, can we integrate it to our Microhawk?
Let's get in touch.
Yeah, let's stay in touch. And thank you, Paul, for having me. And dude, Jeff and Paul, that's awesome. You're doing the Part 107 course. That's a really cool thing, because like kids really need to be able to do that. And I feel like that's definitely a leg up on the industry, you know, going out of high school with a professional license to do commercial work with drones is huge. That allows them to jump into several different career paths, from videography to mapping to inspection work. And those are growing industries. And that's one of the last points I want to make before I go. We are at the very start of the drone age. You know, drones were really not a thing up until 10 years ago when DJI created their Phantom series, and it's taken about 10 years for them to get to the point that we are now. You know, where were automobiles after 10 years? where was any technology after 10 years of being into existence? It was still very new. And we're just seeing the very beginning of what's going to be the next revolution in robotics. So I want to say thank you all. Keep pushing. We're going to get there in 20 more years to where it's going to be crazy. You know, I hear you, you know, the whole DroneBlocks with the Tello, you're teaching kids how to do swarming. So congratulations on introducing them to Skynet. That's very awesome of you. And yeah, I'll give it up to Marisa.
Thank you. This has been a treat and honored that you have us on here. And as you know, you all kind of touched on this, is I'm just so glad that we can provide this opportunity. I feel like I had so many opportunities growing up, but I had no idea this type of thing was an option. One of my nieces asked me the other day, you know, what I want to be when I grow up. And honestly, if I did it again, I think I would be a commercial pilot. But growing up, that's something that I don't know if it's because I'm a girl or that's just, it never crossed my mind, but that's just something I never even thought as an option. And what we are all doing is giving children the exposure to so many different things in hopes that they'll take it to, you know, solve the next problem or just continue and like Zoe said, make our country great and competitive. I appreciate so much what you are all doing. And as I said before, if you are not a computer science teacher, you don't have that background, start with checking out any of our websites or take a look at DroneBlocks.io. And we've really tried to make it so any teacher can come in and start with our introductory lessons and at least try it out. And we just hope that as an educator, you will give those opportunities to your students. Thank you so much.
Hey, thank you so much, Marisa. Somehow I got dropped out here. I appreciate
it.
What's that?
We kept it going. We thought you had enough after Jeff.
I appreciate that. I jumped on there. I was like, hey, Zoe's rolling right into it. And then she just rolled it right to Marisa. I was like, hey, I don't even know. I'm going to go have dinner. But yes, thank you, everybody, for joining and participating, to the folks that are watching this live, and then folks who will be watching this on YouTube at a later date. The people here on this panel right now, between Marisa, Zoe, Jonathan, Jeff, and myself, we're representing a really wide range of what's happening in the industry. So if you're a teacher and you want to know more about integrating drones from the perspective of a teacher, I mean, Jonathan McRae is someone that you can reach out and connect with. If you're wanting to learn more about specifically drone blocks and like from an educator standpoint, you can reach out and connect with Marisa. That's how we connected, just from reaching out through different folks. If you want to know more about this crazy FPV flying drones both directions, you'll never get a Phantom 4 to do that. I don't care what code hack you do. Reach out to Zoe, find these folks. Zoe, like she said, at Outcast DroneWorks, Marisa with DroneBlocks, and then Jeff with STEMERALD City. If you want to know about from the applicator side, and Jeff just shared his email address within the group, and any of you, Jonathan or Zoe and Marisa, please do, you can share your contact information in the chat, and then I can tie that into the follow-up video. But please do reach out. This is a community. Like Zoe said, we're at the very beginning, which is a good thing because it's a small group of folks, and everyone is open to sharing and helping with ideas. Thank you everyone for tuning in. I did want to say, like Jeff said, we're doing that 107 training. So if you're a high school student, you want to reach out, you want to take this online learning and then move into that virtual classroom, please do reach out. Another big thing about this is we're just at this point of education. People don't know what they don't know, and that's why industry isn't using drones as much. So if we can get high school students, that 107, right? That could be that ticket that actually helps them get into college, because they show a college that they have a 107 and they have that desire to learn more. So they go to a college. Now that student, that 18, 19-year-old student, has an opportunity to introduce drones to that college, whether it's a club or in a class. That's how this is going to grow. And unfortunately, as Zoe said, maybe it might take 20 years. But no, we all know based on what's happened in this 10 years and 20 years, it's going to be crazy. Thank you very much. I think that we may do some follow-ups to this event. We may have to do just an event regarding builds specifically. I think Zoe would probably be into that, and Jeff. Maybe we do an episode where it's just about coding and programming. And Marisa, we have you back and we bring on some of these other folks from around the country and globe that are hitting programming hard. And I think the mapping itself could use maybe its own little event. So if anybody's interested, please, that are watching, reach out, let us know that you'd like to know more. And I think that we can make that happen. So again, thank you everybody for tuning in. Thank you to all the panelists that gave their time today. If you have any questions, reach out to them. You can find 910 Drones, 910drones.com. You can catch us on Instagram, Facebook at 910 Drones. We're going to post this up later on within a day to YouTube. Please share it with anyone you know. One thing I want to hammer home is I think we all know a teacher. We all know a teacher, substitute, part-time. We know an educator who's working with children. So when we share information like this with our networks, you just don't know who it could reach. And yeah, thank you everyone for tuning in. Thank you all the panelists, and have a great evening.